All right, good afternoon, everyone. Welcome to another exciting day in mathematics. Whoop, whoop. And I'm gonna upload this video in lieu of or in exchange of the other one that was live stream. I know that the screen's froze. Let's see. Hopefully, this one will work out a little bit better. So, with that said, our warm up for today is warm up 120. And it reads number one, solve, graph, and write the solution set. And they give us the absolute value of x minus 5. And outside the absolute value, you've got minus 1. And all of that over 3. Greater than or equal to 3. So for that one, once again, solve, graph, and write your solution set. Number two, solve by completing the square and allow for imaginary numbers. And we have x squared plus 2x minus 9 equals y. Number three, graph f of x equals parentheses x plus 3 close parentheses squared minus 6. And number four, write in slope-intercept form and graph 4x plus 2y minus 14 equals 0. Now all of these are just a review. By now you should know how to do these by yourself. If not, go to your notes. And just really quick, if you notice the first one, you just need to isolate the absolute value and solve for x. You have to make two inequalities and then graph and so on and so forth. For number two, you need to set it equal to 0, eliminate the 9, so you add 9 to each side and complete the square, and then you factor, and then that's how you get both your x's. Number three, you graph f of x equals x squared first, which is the parent function, and then from there see what transformation happens with the given function that's there. And number four, write in slope-intercept form and graph. They give us 4x plus 2y minus 14 equals 0. So on this one you need to isolate y or solve for y, and then once it's solved for y, then you use your slope and the y-intercept to graph that line. All right? And once again, you can pause the video at this moment so you can copy that and work those out. However, I'm going to keep going. All right, so let's see. All right, so with that said, our home plate for tonight is page 770, all only. And for this home play, I haven't given you a Nearpod code. Once again, I've been having issues with uploading stuff to a different program because I'm switching computers. So for today, just do the home play and hold on to it, and then on Thursday when I give you the other one, I'm gonna have you turn in both together. And just a heads up, we turn in grades for the progress report this coming Monday. So if you need to act like tomatoes and catch up with your home play and your notes, make sure you start sending those in through Nearpod and through email in case you can't log in through Nearpod. Once again, our home play for tonight is page 770, all only. Our objective for today, I can graph logarithmic functions. Once again, I can graph logarithmic functions. All right, so if you notice, we're still on the same function, same logarithmic functions, but today we're going to continue with graphing. Last week we started with, I gave you guys one problem for graphing and one problem for home play also with graphing. Today we're going to continue, and once again, for your Cornell Notes, you should have a fair model for logarithmic functions or logs, and you should be able to fill this out by yourself. By now you should know the definition of logs, what they look like, what they don't, and the attributes, some hashtags. Alright, it should look something like that, but you can do that on your own. Alright, and also a quick recap. Last week, once again, we started with logarithms, and I gave you the basic one, which was this one, x equals log b of a, and we said that b is the base, a is the given number, and x will be our exponent. And that means if I was to give you this, it translates this logarithmic function, the inverse of it is an exponential function, so the base is b, the exponent is x, and the given number is a, and that's how we write it. And we did some practice ones and we got to that. Alright, and then from there we got to this one, and from there we were given a function, and you needed to evaluate given some values, and they gave us 3 different values for each. So this one is f of x equals log 7 of x, and then we needed to substitute values in there, and so on and so forth. And you guys remember that, right? All right, but today I want us to look at some differences in regards to the different logs that we are going to be looking at. We know how to change this into exponential. So for right now, copy this one, f of x equals log 2 16, and then draw a line down, make another column, and write f of x equals log 100. Draw a line down, and then write f of x equals ln x. And yeah, and I'll elaborate on those. Okay, so on all these, out of these three, the ones that we've seen so far is this kind. We haven't seen this one or this one. So I'm going to elaborate on these two in a little bit. I'm just going to do this one and change it into an exponential form. But before I do, who notices that I have something different on one of these? Yeah, this one. This one is blue, ln. This is what we call a natural log. Natural log. It's got L and N. And the reason they're backwards, instead of writing NL as such as natural log, they have it as LN, is because it's in a different language when it was first written. So it was Logarithm Naturali. So it's a different language. That's why they had it as LN. So but with that said, the ln stands for natural log, and the natural log is what we know as the letter E. And I don't know if you guys remember from Algebra 1 when we covered real numbers and rationals, irrationals, and I said, and later on we're going to be talking about E. Well, this is the time we're going to talk about E. So right above that, I want you to write E is approximately 2.718. E approximately is 2.718, and that's the value of ln. And we'll get to that one in a little bit. All right, but before we get to that one, let's go ahead and do, let's change this one to exponential. So to change this one to exponential, this automatically changes to what? Y equals to log 2 16. And now we can change it to an exponential form. What is our base? Yeah, our base is 2, so we write 2 for the base. What is our exponent? Y, and all that equal to what? 16. You guys remember this? Yeah? And I'm just having you guys rewrite it, but if we wanted to solve for y, then and both sides need to have the same base. So this one is, if we start with base 2, 2 times 8, this is 2 times 4, and this is 2 times 2. So this could be written as 2 to the 4th power. So if we rewrite this, this is 2 to the y equals 2 to the 4th, and now at this time we can actually match these up. So this is y equals to 4. Does it come back? Yeah, right? So let's go to this one. So I don't know if you notice on this one's missing something. Yeah, it's missing the base. So this is kind of like when we cover, remember when we combine like terms, and that when they gave us a variable that it didn't have a factor in front of it, such as this. Remember when we had a variable like this, and I said there's an invisible number here? What was that invisible number? Right, 1. However, for logs, it's not 1 when it's an invisible base. When there's an invisible base, guys, automatically know that when it doesn't have a number here, the number that you should assume is that we're going to be talking about is base 10. So fill that in like that, so you guys remember that whenever it doesn't have a base, it's going to be base what? That is correct, base 10. And now we can do the process just like we did over here. So this becomes y equals log 10 to the 100. So with that said, what's our base now? Our base is 10, so it goes here to the power of y equals to 100. Do they have the same base? No, this is base 100, this is base 10, so that means I need to divide this by 10. 100 divided by 10 is 10 and 10. Okay, so how can we write 100? 10 to the second power, so this is 10y equals 10 to the second power, and right there now we can actually solve. So this is y equals 2. So far so good? Yeah, right? So the only difference, yeah, some of you are like, so the only difference, Mr. Q, if it doesn't have a base, we just put a 10. Yeah, it's going to be base 10. Okay, make sure you keep that in mind, because today, for tonight's home play, you're going to need that for one of the problems. Okay, now let's go to the last one, this one. What do we know? That this becomes y equals ln x. All right, and you're saying, Mr. Q, that one also doesn't have a base. I know, but because this is special. This ln, I'm going to circle it here. This ln is replaced by e, but we don't write it here. I'm going to write it now as a base over here. So this is replaced by what? That is correct, base e. So base e goes here. That one became that. So what is my exponent? My exponent is y, and all that equal to, what is the given number? X. And this is how you write it. So that's the only thing you need to know. For right now, you are giving the value, which is 2.718 approximately. And the way we get that is basically we derive it from an exponential function. And the exponential function, it keeps growing by a 100% at every interval. I'm not going to get too into that for right now, because that's basically stuff that you're going to do with a calculator, and I just want to save that time to focus on the graphing for today. All right, but just know that E is approximately 2.718. All right, let's continue. So last week we left off with this one. I said the f of inverse of x, a log 3x, was the inverse of this exponential function f of x equals 3 to the x power. And then we graphed those, and they look like this. The blue one is the exponential. The red one is the log of 3, which is the inverse of the exponential. And then I said if we draw this dotted line, and that dotted line is going through y, is this line is actually y equals x. So if you go one up, one to the right, one up, one to the right, there it is. These points are reflected same distance from that, and that's how we get that. And how do we graph this piece, the log 3 of x? I said you need to choose a value to substitute for x that is a multiple of 3. So this one we chose 0.3. This one we chose 1 because any number to the 0 exponent will always give us 1, so we need to include the 1 all the time. And then the next number that's a multiple of 3, or 3, that's why we wrote 3. So today, just to get some practice, copy this one. Example 1, graph f of x equals log 2 of x. And then from there, make a table. And that table is going to look like this, just like what we did on last week. X, and here we would write what? F of x. However, I'm going to write it like the book presents it. The book presents it, instead of just writing f of x like we usually do, they actually write the entire function in there. So like that. So write in there f of x equals log 2 of x. What does that mean, Mr. Q? It doesn't mean anything. It just means that we're going to do exactly what we did with the other one, but now we just label it like that. So the reason I'm going over it like this, so that you don't get all like, oh, Mr. Q. All right. So first value. I'm going to do this in blue. Let's see. So I'm going to start with, I'm not going to start with 0, because 2 to the whatever power, there's nothing that gives me 0. So I'm going to start with 1/2. 1/2. In decimal form, that's 0.5. And I'm going to write it here in decimal point, in decimal form, so that you guys can see that the 2 has a multiple of 1/2 because the denominator is a 2. So let me change this. If I was to change this, how do I change f of x so I can make this into an exponential? Right, this becomes what? Y equals log 2 of x. All right, so now that I have that, what is my base? 2, so that is 2. What is my exponent? Y, and all that equal to x. But instead of x, what am I going to substitute? 1/2. All right. So, are they the same base? Kinda, but this one's in the denominator, needs to go where? Up here. So that means the exponent should be what? 2 to the negative 1, and all that equal to 2 to the y. So if I was to, now that we have the same base, oh, sorry guys, my fingers are getting stiff, y equals negative 1, so that goes right here, negative 1. Alright, so if we make this a multiple of 2, because it's base 2, so what is 1/2 times 2? That is right, 1. Alright, so then again, what is my base? And let me change the color so you guys can see the work. My base now, so I'm going to use the same one, y equals log 2 of x. My base is what? 2. Exponent is y, and all that equal to x. But what is x now? 1. Alright, so question. 2 to the what power gives me 1? Right, any number to the 0 power is 1. Okay, so that's this side, and the other side we have 2 to the y, and what do we know? That we put these equal to each other, so this is what? 0. Alright, let's do the next one. Let's see, this was 1/2 times 2 gave us 1. 1 times 2 is 2. Alright, so then I use y equals log 2 of x. And what is our base now? Again, 2 to the y equals, what is x? What are we going to substitute? The 2. Are they the same base? Yeah. What is in the invisible exponent here? 1. So we know if this is equal to that, so this is 1. Alright, question, what would be my next value for x that I'm going to use? Let's see, 1/2 times 2 is 1. 1 times 2 is 2. So 2 times 2 is, that is correct, 4. So then I would be at y equals log 2 of x. Base, again, is 2 to the y power. And instead of x, what am I going to substitute? 4. I'm going to go this way. So 4 can be written in base 2 how? 2 to the what power? That is correct. So I end up with 2 to the y equals 2 to the second. So that means that y is 2. Alright, I'm going to plot those points. So I'm going to start with this one, 1/2 negative 1, 1/2 negative 1. The next one is 1 of x, 0 of y, 1 of x, 0 of y. Okay. The next one, 2 of x, 1 of y, 2 of x, 1 of y. There it is. And the last one, 4 of x, 2 of y, 4 of x, 2 of y. There it is. All right. So what does that look like? So I'm going to graph that with blue. Something like that. So for home play, they're going to ask you to graph this one again. So these are the notes. So that when you send me that, this is part of your notes. But on the home play, you're going to redo it by yourself. So try to do it without looking at your notes. You already saw, again, the process as we are doing it. But then they're going to ask you to graph the next one, which is, let's see. The next one that they're going to give you is this one. Hold on. Let me change this. Alright. So they're going to change this like this. And they're going to ask you graph f of x equals log x. So what do we know about these guys? That if it doesn't have a base, what do we assume? That's right, that it's what? Base 10. So automatically when they give you something like this, you're going to write right here what? 10, and a 10. And then you know what to do from there. What would be a decimal form that's a multiple of 10? Yeah, 0.10, and then from there 1, and then so on and so forth. All right. However, I'm not going to go over that one with you. You're going to do an exploration. You're going to actually go to Desmos. So let me go to Desmos really quick, and I'm going to show you exactly what I want you to do there. So I go to Desmos, and it says start graphing. Yes. So when you get to this point, so the first one that we graphed was, so here you just start typing f parentheses x equals 2. And then right before you type in the log and all that, don't type it in. I want you to go down here to the tool, this keyboard right here, or keypad. You click on the up arrow, and then you're going all the way to the right where it says functions. You click on that, and then from there you go to miscellaneous. And in miscellaneous, you see how down here it has log, or log of a, or natural log. So it has all the logs in here. For this one, I'm going to go with this one, log of a, because it has a base here. So log of a. And if you notice, the little cursor is blinking right there where the base is at. And what is the one that we just graphed right now? It had base what? 2. So I'm going to put 2. And then this was x. Close parentheses. And here's our graph. Now, is that what our graph looked like? Let's see. Yep, there it is. Check this out. Bam, we have 1, 0, 2, 1, 4, 2. Let's see if it's true. Let me zoom out here. Let me bring this down again. Let's see. Oh, let me zoom in the other way. 1, 0, 2, 1, 4, 2. Yep, there they are. Now, if you really want to see the points, or if you want to check your work, which I recommend, this is what I want you to do. You're going to go here to the gear, click on it, and then it's going to say, it's going to give you these two options. I want you to go to the table, convert it to table. Click that, and here it's going to give you a table with values. So what are the values that we used? We used 1, yes. What else did we use? 2, yes. What else did we use? 4, yes. And what else? We used 1/2, didn't we? So let's put 0.5. There it is. And let's see. Here's 1/2, negative 1, 1, 0, 2, 1, 4, 2. And then we typed in, 4, 2, there it is. And there they are. And that's how you can check your work. So when you have that on paper, on the same graph, the paper in your book is going to give you the graph. They're going to ask you to graph the next function, which is log of x without the base. So graph it first, do it all by hand, the second one. And then from there, come over here and then type in what they're asking you to graph. So it would look something like this. And of course, you go here, you get your table and check your work with the table. However, the last one, you will not be able to show work because that's the new natural log. So for the natural log, remember, start with f of x equals 2. You go down here to the keypad, go to the functions, to miscellaneous, and here you're going to have the what? Natural log, ln. Type that in, see what it looks like, graph it, and then you're going to graph it on your paper using some of the points that you have referenced there. All right, guys. Well, I hope that helped because I know that with glitching from today's live stream, and plus we had some trolls or whoever it was. Come on, guys, you can't be interrupting like that. Stay focused on the lesson. So our objective for today was I can graph logarithmic functions. Did we cover that? Yes. Are we going to do some more practice? Yes. And remember, Thursday we're going to be doing transformations using logarithms. But it's a piece of cake because it's the same thing we've been doing all year, but now with logarithms. Okay. All right. So really quick. So our home play for tonight is on page 770, and I'll only bam. And remember, guys, if you're not moving forward, then you're already behind. All right, bam from the corner. All right, guys, keep up the good work. See you guys till Thursday. Love you guys. Peace.